Listen to the wind howling against these rusted hulls. What you are looking at is the end of the line for the true titans of our world. For 20, maybe 30 years, they have battled rogue waves, crossed brutal oceans, and carried millions of tons of global trade on their steel backs. But no matter how massive, every ship eventually loses its battle with time, salt, and rust. This is the shipbreaking yard, a graveyard where giant vessels come to die. But in the world of heavy industry, death is an illusion. It is simply the first step of a spectacular, violent reincarnation. Today, we are taking you inside a mega factory
to witness one of the most extreme recycling transformations on the planet. We are going to track the rusted, decaying steel as it is ripped apart, melted in an artificial thunderstorm, and beaten into a flawless, unbreakable 300-ton crane hook. This isn't just a recycling process. It is a battle of extreme heat, earth-shattering pressure. To build something indestructible, you must first destroy what came before. The ships beached here are constructed from marine-grade carbon steel. It is incredibly tough, designed to flex under the pressure of the ocean without snapping. But it is no match for the hydraulic guillotines of the scrapyard. Machines equipped with hydraulic shear jaws, capable of exerting hundreds of tons of bite force, slice through the ship's hull like scissors through paper. Jagged, rusted panels are ripped away, exposing the skeleton of the vessel. But these massive, awkward chunks of metal are useless to a foundry in their current state. They need to be condensed. The scrap is loaded onto miles of reinforced conveyor belts, carrying the metal deep into the processing facility. Here, robotic arms equipped with electromagnets sort the steel, separating out non-ferrous metals and debris. The pure steel scrap is then dropped into a colossal hydraulic compactor, with thousands of pounds of pressure per square inch. The walls of the baler close in, crushing the ship's armor into dense, uniform cubes.
The beast has been packaged. Now, it must be fed to the fire.
Welcome to the melting floor. This isn't a traditional coal fire. This is an electric arc furnace, a cauldron that harnesses the raw power of lightning. The compacted steel blocks are dumped into the belly of the furnace. The roof slides shut, and 3 massive graphite electrodes are lowered directly into the scrap. The operator hits the switch, and tens of thousands of amps of electricity surge through the electrodes.
Artificial lightning arcs across the metal. The sound is deafening, like a continuous thunderstrike.
Within minutes, the temperature inside the crucible rockets past 16,600 degrees Celsius. The steel doesn't just melt, it violently liquefies.
Engines.
But a crane hook cannot be made of standard ship steel. It requires something far stronger. They introduce a precise cocktail of elements into the molten soup: chromium for hardness, molybdenum for tensile strength, and manganese to increase toughness. The impurities, a rocky substance known as slag, separate and float to the top, where they are skimmed off. What remains is a pure, liquid superalloy. With the alloy perfected, the furnace tilts, unleashing a blinding waterfall of liquid steel into a transport ladle.
The radiant heat in this room is so intense that workers must wear specialized silver-lined proximity suits, just to stand 50 feet away.
The molten steel is carefully poured into towering, rectangular casting molds. As the ambient air hits the metal, it begins to cool and solidify, transforming from a liquid into a massive, rectangular block known as an ingot. Now, you might be wondering, why not just pour the liquid steel directly into a mold shaped like a crane hook? Microscopics. The answer lies when steel is cast in a mold, its internal grain structure becomes rigid. If you tried to lift 300 tons with a cast hook, those microscopic flaws would cause the metal to shatter like glass. The glowing ingot, still radiating at over 1200 degrees Celsius, is moved to the forging press. This machine is a mechanical titan, capable of delivering up to 10,000 tons of downward hydraulic force. The hammer drops. With every earth-shaking strike, The brute force compresses the atomic structure of the steel. This process is called open die forging. It obliterates any internal air voids and aligns the crystal grain of the metal so that it flows continuously along the shape of the hook.
This uninterrupted grain flow is the ultimate secret to the hook's legendary strength.
It is a brutal, yet deeply artistic dance. Operators sitting in reinforced glass booths control massive manipulator arms, rolling and turning the multi-ton block of glowing steel as if it were soft clay. They flatten it, elongate it, and finally, place it over a specially curved die. The hammer comes down one final time, forcing the red-hot steel.
Brute force has given the hook its soul, but it needs surgical precision to function.
Once the steel has cooled to room temperature, it is transported to the CNC machining sector. Here, computer-controlled mills armed with diamond and carbide-tipped cutters. The most critical moment is the drilling of the shank, the top eye of the hook, where it will connect to the crane's pulley system.
This hole must be bored with microscopic accuracy. If the alignment is off by a fraction of a millimeter,
the 300-ton load will not hang dead center. An off-center load can cause massive, dangerous swinging, threatening the lives of everyone on the ground below.
The hook looks perfect, but it is not yet ready. The machining process has left the steel slightly soft.
to lock its superhuman strength into place, the hook must face one final violent shock.
Then, it is rapidly plunged into a massive bath of specialized quenching oil or water.
This causes an extreme thermal shock.
This gives the hook an incredibly hard, wear-resistant outer shell. Afterward, it is gently reheated and cooled slowly in a process called tempering. Having survived the fire, the hammer, and the quench, the hook is complete. Automated grinders give the metal a final polish. It is then coated in thick, anti-corrosive industrial yellow paint, a universal symbol of heavy lifting and extreme caution. Finally, high-contrast black hazard stripes are masked and painted, and the ultimate badge of honor is stamped into the steel, 300 tons. From a decaying, rusted ship left to die on a lonely beach, to a gleaming titan of modern engineering, it is the ultimate cycle of industrial reincarnation. Because in the world of heavy metal, nothing is ever truly destroyed.